We want to draw the forces on these boxes, and we are told that this surface over here is frictionless, but there is friction between the two boxes over here. And we are pulling on the bottom box with some force F. So there's a rope attached here, we pull with some force F. So what are the forces acting on each of the two boxes? So let's start with the bottom box. We know there's going to be a force of gravity over here. So there's going to be, actually let me make this a big M. So big mg. So that's the force of gravity on the big box. And there's also going to be a normal force on the big box. And so let me go ahead and draw this normal force. And you will notice this normal force I have drawn is bigger than the weight. So this arrow over here is bigger than this arrow over here. And the reason for that is that, well, there's another force that is pushing down on the big box, which is this guy, right? There's a normal force between these two boxes. These two boxes are touching. So this top box is going to be pushing down on the big box. So there's going to be another normal force here. And I'm going to call this force just N. And so to differentiate this normal force from this normal force, I'm going to add a subscript B here because it's the normal force from the bottom, okay? And finally, we know that there's going to be a force of friction, right? And so what's going to happen, right? So if I yank too hard if I yank this guy too hard and this guy gets left behind, there's going to be rubbing, and the rubbing is going to be from this guy moving to the left. So that means that friction is going to try to oppose that, and so it's going to be a force down here to the right. So there's a force here to the right, which is the force of friction. Now for the top box, we have a weight here, which is mg. This is little mg. And we also have the corresponding normal force, right? And notice this normal force and this normal force are equal and opposite, right? So they have the same length. So my arrows here have the same length. And finally, there is a force of friction. So the force of friction is going to try to drag the top box along with the bottom box. So here's my force of friction. And once again, this force of friction here is equal and opposite to this frictional force here. This friction is the bottom box pushing on the top box, and this force of friction is the top box pushing on the bottom box.